I don't know if you all remember being a kid and having to do a division problem, and in the heat of the moment, you kind of forget certain multiplication facts and you just start subtracting and counting them, right? I remember doing that, like down the side of my paper. Or I would write out things like, let's see, 7, 14, 21, multiples of 7, hoping to help me figure out what the division was. Division was just hard. Now, the problem with repeated subtraction for something like this is it takes a while, so we might say like 861 minus 7. Oh, we gotta borrow, darn it. So that's gonna be a 5 and a 1. And so I'm gonna get a 4 and an 85. And then I get to subtract again. And I just keep doing this over and over again. And we gotta borrow again. So let's see if I subtract there, I'm gonna get a 7, and then that's going to be an 84, and I subtract again, and this is going to go on for a while. Okay, so, but I could do it if I had to. I don't really want to, but it's doable. So dot, 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 and eventually we get close to 0. Close to 0 as we can get without going past. Sometimes we get there, no remainder. So next up, because that seems a little bit too painful, is grouped repeated subtraction. And groups that most of us are really good at, like I'm really good with groups of 10, because 10 sevens is 70, that's easy. Or even better, in this case, 100 groups of 7 is going to be 700. And I could do that, right? So over here onto the side, I could say, all right, let's take 861, and we're going to take out 700, get 100 sevens out of there in one shot. So that's going to give me 161. And I could make a note off to the side. That's 100 sevens that I took out there. Well, let's see. I can't take out another 100, but I could certainly take out 70 of them, couldn't I? And actually, could I take out more than 2 groups of 10? So 2 groups of 10, that would be 27s. I can handle that. 7 times 2 is 14, so that would be 140. I can do that here, couldn't I? And some kids would just notice 70, and that'd be fine. They take out 70 and they subtract it, and they say, oh, I could do another 70. That's cool. So there's options here. I'm going to say we're the kids that noticed we could take out 20 of those. And that subtraction is going to leave us 21. So I'm going to make a note. I took out 20 of them there. And then, oh, wait, 21 times 3. Yes, I love that one. So I can just take away 21 and get 0 and note that I just took away 3 of them. So altogether, I took out 123 sevens to get my answer there. And again, there's lots of different groups kids might take. Like some kids might not have noticed the 20 groups of 7. They might have done 10 groups of 7, then another 10 groups of 7. Some kids might remember facts like 5 groups of 7 is 35, and they could take out 35 at a time. But just keeping track of those groups. It's a little better than 1 at a time. Agreed? Yeah. And early on in elementary school, before we get to big numbers like this, we do repeated subtraction to divide. That's the way we teach it. It's our groups in method. How many groups of 7 are in this number? There's 1, there's another. We just keep going that way. Okay, next up, scaffolding division.
You say that like it's so much fun.
It is. Come on, it's division. It's kind of sort of fun. I learned to love division only as a teacher. When I was teaching adults that didn't know how to do a long division, I thought it was gratifying. All right. So the way scaffolding works is instead of writing a division symbol like we saw before, and this is kind of an important distinction. I'm taking 861 and I'm dividing by 7, which is the same as saying 861 divided by 7, or even as a fraction, 861 divided by 7. We have this new symbol that doesn't work the way these do. I'm going to call it the goes into symbol. Because I got to write it backwards. I got to write 7 goes into 861. And that's going to cause confusion for some kids. Because all of a sudden, we're writing it backwards. Why did they do that to me? I thought we wrote it the other way. And they're going to be confused about which number goes where. So to emphasize that difference, because it is different, right? It's backwards. Don't call it the division symbol. Call it the goes into symbol. Acknowledge that it's different to get used to that. The way scaffolding works is we work on place values. So it's kind of like the group repeated subtraction. Can we take 100 or so 7s out of 800? And the answer is yeah. We can take out 100 7s, which is 700. So we fill in all of the place values. Subtract, we get our 61. 161, excuse me. And then often with division, there's scribbling off to the side, and we should encourage that. We shouldn't expect them to all, in their heads, come up with the next answer. So I'm thinking off to the side, well, I know 10 times 7 is 70. And if we double that, that's going to give me 7 times 2 is 14, so 140, right? Explain that process to the kids. We couldn't do 3 of those, right? If I tried to triple that, that's going to be another 70 or 210 we could eventually come with. That's too many, right? So that's too far. So we like this one right here. So I'm going to put the 140 there. How many 7s is 140? 20 of them. So I'm going to write the 20 above, like that. And then we do our subtraction. We're going to get 21 left over. And here's where we finally get to, oh yeah, 3 of those 7s are going to give me this, and I can get no remainder. So then here I can see the answer has to be 123. So when we use the whole place value, that's called scaffolding. And another thing I remember from being a kid and being around kids is problems that required more steps like this. They kind of curve. Did that ever happen to you? The curving division, it just kind of, for me, it always slipped off to the right. Just curved off to the right. I had a hard time keeping it straight. But somehow having those place values in there, putting all of them in, those extra zeros where necessary, right, is helpful to keep things lined up. So with messy kids, I would give them graph paper with, big enough chunks in the graph so each digit could go in a square.
We usually have them turn our notebook sideways.
Oh, turn the notebook sideways is beautiful, right? Because then the lines go straight down, and that's an awesome way to do it. Very nice. I love that. Sideways lined paper to line up your division. Beautiful.
We also teach them like the decimal point where you go tens, hundreds, thousands, ones, tens, hundreds. We usually keep it this way too.
Yeah.
Just because they're able to keep it in.
The place values have a column to be in. That is awesome. So again, scaffolding division, it's a nice way to do it to keep track of the powers of 10. If kids are having trouble with the long division with those empty spaces, this could be a way to help keep them in line, help them keep track of what the answer means by keeping track of place value. Because one problem with our algorithms is they use it as a minimal amount of ink for the most part, but we also like blow off what the place values mean, right? If you don't get what I'm saying there, let's look at long division for this. So with the long division algorithm, we use the goes into symbol. So 7 goes into 861, which many of us have slip into slang sometimes and call that 861. And being a math teacher in an elementary classroom, we should try and avoid slang like that to help remind students to place value. But in the long division algorithm, I don't know about you guys, but I was taught to say, does 7 go into 8? And totally ignore that it's 800. Totally ignore it. Yes, 7 goes into 8 once. Put the 1 above the 8. 1 times 7 is 7. Keep things lined up. Subtract. Bring down the remainder. Bring down the next digit. Why only the next digit? Because I said so. It's the rules. And then we repeat, does 7 go into 16? Sure. 2, but not 3 times. 2 times 7 is 14. Subtract. Remainder 2. Bring down the next digit. And on long ones, I would often like draw these lines coming down to keep myself lined up. Let's see. Yes, I remember that. 3 times 7 is 21. Are there going to be lots of kids that are going to struggle with 3 times 7? Yes, there will. What do we do with that? Don't make them feel bad. They're trying to the best of their ability. A multiplication table would be a great thing to have right next to the kids when they're doing this. So look at the chart and say, oh yeah, 3 times 7 is 21. I remember. There it is right there. Now I'm sure of it. So multiplication table is a great idea. So again, notice the similarity between the long division and the scaffold division. The scaffold division keeps track of those powers of 10. Not a bad idea. All right, so we've got the most basic algorithm, right? Oops. The repeated subtraction, that can be kind of painful for bigger numbers. Group repeated subtraction is kind of cute. Scaffolding, where we think about place value and use the zeros in our place values. And long division, where we strip all those zeros out. Is this hard? Yes, this is hard. Kids really struggle with that. Adults struggle with this. Like when people take a placement test when they haven't been in school for a while, 2 biggest things they're going to struggle with on the placement test is doing division without a calculator and playing with fractions without a calculator. Crushing. But people are easily reminded. And how many people study for a placement test? Nobody. Okay, it's not a bad idea. All right, short division. I love short division. I think it's so cute. Yes, math can be cute. So short division is taught in many countries around the world. There's several Central American, Latin American, European countries that do it this way. And the thing about short division compared to long division is we pretty much don't write that step right there. We don't write that step right there. We do all the multiplication and subtraction in our heads, okay, which takes some focus. And there are some days I can't quite make that focus happen. But most days I can. So let's try it on this 861. So again, the way it goes is we make our guess 1 and we write that. 7 goes into 8 one time. But we don't write for a moment. We say 7 times 1 times 7 is 7. 8 minus 7 is 1. And we write the 1 as a superscript just to the right of the number digit we were working on, like that. So that's my remainder. Now I can see that 16 is the next number I need to consider, right? The 1 6 here. 7 goes into 16. Yes, 7 goes into 16 twice. 2 times 7 is 14. 16 minus 14 is 2. So I write the remainder 2. And that means 21 is the next number I need to see if 7 goes into. 7 goes into 21 3 times. No remainder. Don't need to write anything. And I'm done. That's called short division. And it's taught in several South American, Central American countries, and some European countries. in the old days, they used to force kids to do all of that as soon as possible. I think now they have like a long division. Let's just warm up with long division and then move to short division. All right, something that's kind of in between Portuguese division. I bet it's in other countries too, but I've seen it in Portugal. So Portuguese division. So they don't use the goes into symbol. They just use the bar with the dot. So they would write 861 divided by 7. And then they put a bar under the divide by 7. And then it's kind of like the short division in a sense. They say, okay, the 7 go into 8. It goes in 1 time. So they're going to write the 1 under the 7. And then they're going to say, okay, let's see, 7 take away 8, 8 take away 7 is 1. They're going to write the 1 and the next digit underneath. So they're going to do the subtraction in their head, write it down, and they're going to bring down the next digit. So they're just going to write basically the next whole remainder. And then they ask themselves again, okay, does 7 go into 16? Yeah, twice. So they'll put a 2 over here. And then in their head, they say, okay, 7 times 2 is 14. 16 minus 14 is 2, and they bring down the 1. And then the 7 going to 21 3 times, and then they're done. They're not going to write anything else. If there was a remainder, they'd write the remainder underneath, but if it's a 0, they don't bother writing the 0. But you could say 0 if you wanted. And then they're done. So it's like the short division, but they orient it a bit different.
I have a coworker who is from Brazil. I'll have to ask.
My guess is in Brazil, they probably learned the short division, and the lattice multiplication is popular in South American countries. Did anyone watch my video on lattice multiplication? You started it? Okay.
I was gonna take notes this weekend before Monday, and I got here